Welcome to our lecture on dplyr basics. dplyr is an R package that provides a grammar of data manipulation. Basically, it makes it easy to carry out common data wrangling tasks that can be tedious in base R. Its syntax is intuitive, simple, and it's pretty fast. The main competitor to dplyr is a package called data.table, and the trade-off is roughly that data table is somewhat faster, but is usually considered a bit harder to understand. If you find yourself facing this trade-off, you may want to check out the package dtplyr, which allows you to capture the best of both worlds. But for today, we're just going to be focusing on dplyr. So as usual, my lecture barely scratches the surface of a given topic, and it's more of a jumping off point for you to learn more rather than a comprehensive introduction. So here I'm listing some resources that will be helpful if you need to learn some more about dplyr. First is the dplyr cheat sheet. Next is a chapter from the freely available online book R for Data Science about using dplyr for data transformation. And finally is the dplyr function reference. Here's a little example. I've set up a data frame with some fake data for some fake employees in a fake company. Their name, age, department, and salary. Don't worry about how I set up the data frame. Let's just pretend we're starting from this employees data frame that you can see on the slide. Now, suppose that I wanted to select only the employees whose age is over 30, that I wanted to sort these employees' records in descending order by their salary, and then I wanted to select only the columns name, department, and salary. On this slide, I show two different ways of achieving the same thing. At the top is the base R approach, building on what we learned in our very lengthy lecture on base R programming. And at the bottom is the dplyr approach. Now, in theory, you should know everything that you need to know to understand the code at the top of the slide. But if you're anything like me, you find it a little bit forbidding. I mean, look at how many dollar signs are running around in that, for one thing. And look at the complicated combinations of brackets and parentheses. That's a lot of work. And it's also pretty difficult for someone who doesn't know R to tell what that code at the top of the slide is doing. In contrast, let's take a look at the code at the bottom of the slide. Unless you already know dplyr, in principle, you should have no idea what this code is doing. And yet, I expect that based on reading it, you've probably already got a reasonable idea of what's happening. We're taking the employees data set, we're filtering it to just choose the folks with ages above 30, then we're arranging it in descending order by salary, and we're selecting the columns name, department, and salary. I don't know which one you prefer, but to me, the bottom is much more straightforward. And it relies, for much of its elegance, on something called the pipe. So you may have noticed this combination of symbols on the last slide, a vertical bar and a greater than sign. These two things together are called the base R pipe. They have been available in R as a command since version 4.1. To enter this command, you can either type it, or if you don't like typing it, you can go to Tools, Global Options, Code, Editing in RStudio, and you can set a keyboard shortcut. So to do this, you'll need to select Use Native Pipe, and then after that point, you'll be able to type Control-M to insert. So just to be clear, that's a capital M. So Control-Shift-M. We're going to start off by using the pipe. Then I'm going to circle back to explain what it does, because it's best understood in context. dplyr is an R package. Packages are add-ons that extend the functionality of R. That means that dplyr is not a part of base R. To use it, you'll need to install it. You can do this by using the command install.packages, and then parentheses, the name of the package you want to install. You can also install it using the drop-down menus in RStudio. Now, the very first time you want to use a package, you have to install it, but after it's installed, you don't have to keep reinstalling it every time you want to use it. When you want to use a package, you do have to load it, however. So every time that you want to use the package dplyr, you're going to need to type library, and then you put the name of the package inside the parentheses. So you only install once, but you have to load a package every time you want to use it. Basically, every time that you restart R, you would need to load the packages you want to use. Okay, let's start with a really simple exercise. I'd like you to install two packages for me. One of them I've already told you about, the other I have not. But when you encounter something that you don't understand, it's a good idea to get in the habit of figuring it out for yourself by looking through the R help files. So take a look at the help file for Gapminder and figure out what it is. At this point, why don't you take a few minutes, pause the video, and then we can resume. I've introduced the pipe, and the second thing I've got to introduce is what is called a tibble. dplyr combines the pipe with verbs that act on tibbles, and Gapminder, which you just learned about, is in fact a tibble. A tibble is a data frame with some nifty extras. Now, if you wonder why it's called tibble, try pronouncing the abbreviation TBL, which is if you took the word table and removed all of the vowels to abbreviate it. Try pronouncing that out loud a few times. You may find it irritating and annoying, but some people find it funny. So they're called tibbles. For now, let's not worry about the details. Let's start experimenting. So here is a tibble. I'm going to load the Gapminder package using library Gapminder, and then I'm going to type out the word Gapminder. Wow, we get a meaningful and indeed we get quite a clean summary of what's inside this data set. If you're familiar with R and you've ever typed in the name of a data frame in the console before, what you'll normally see is that the console just starts scrolling and scrolling and scrolling until it runs out of space and can't show you anything else. So the first thing we see about a tibble is that it just displays really nicely. It tells us how big the thing is, it tells us what's contained in each column, what type of data it is, and how many more rows we haven't seen. Okay, now we're ready to finally start doing some dplyr. So I'm going to introduce the key verbs that appear in dplyr. The first one is called filter. Filter is used to filter rows. And my preferred mnemonic for this is filter is something about rows, and notice that the last letter of the word filter is R, which stands for rows. Again, filter acts on rows. What it does is it only keeps rows that match a particular logical condition. So if we take the Gapminder tibble and we use the pipe to send it over to the command filter, this is the verb we're learning about on this slide, we're going to filter year = 2007. So that means we're only going to keep the rows of this data set for which the column year is equal to 2007. So as you can see, we've only displayed a small number of the rows, but we now have a new tibble which has 142 rows, many fewer than the original tibble, and indeed all of the years in this tibble are 2007. Now it's important to understand that what we just did has not deleted anything. The original Gapminder data is still there, it's still intact, it still has 1,694 rows. All that we did was filter it and display that filtered data set. So all we did was display a smaller subset of Gapminder without overwriting the original Gapminder data set. If you want to store the results of some kind of series of dplyr operations rather than merely displaying them, then you've got to assign the results a name. So that's what I'm doing on this slide. I have exactly the same dplyr pipeline as before. I send Gapminder into the verb filter with the condition year = 2007. But now I am assigning the result of that pipeline to the name Gapminder _ 2007. This way, if I need to use it again, I'll be able to. And you can see in line 4 of the code example when I type that in, I display this small tibble, the one that is made by filtering the original Gapminder tibble. Filter is a very powerful command, and we can actually supply more than one logical condition if we want. Here's an example where we filter year = 2007 and country = United States. So the comma separates conditions that operate like a logical AND. We're going to filter to select only the rows that meet all of the conditions that are inside the filter command. So there is only one row in this tibble because there's only one entry for the United States in the year 2007 in that original Gapminder tibble. And here we have another exercise for you to start getting your feet wet with dplyr. This will ask you to use filter and carry out some simple operations using the Gapminder tibble. So why don't you pause the video, take a few minutes to work on this, and as usual, you can check your solutions against those on the course website. Our first verb was filter. Our second is arrange. Arrange is a verb from dplyr that can be used to order the rows of a table by the values of one or more columns. So on this slide, I'm taking the Gapminder tibble and I am arranging it. I am, in other words, sorting it or ordering it by the variable GDP per cap. So what I've done here is I have sorted the rows of Gapminder by GDP per capita, and notice that GDP per capita is now sorted in ascending order. So we start with the lowest GDP per capita of 241, and we work our way up. To sort in descending order, we need to use the desc command. So it's exactly as we did before, but now inside of the arrange verb, we're going to wrap the name of the column we're interested in, GDP per cap, in this desc operation. So now we're going to see everything in the opposite order. We are sorting these rows in descending order by GDP per capita. So the rows with the highest values of this variable appear first. Okay, now that you know how to use arrange, you can answer two quick exercises about the Gapminder dataset. Our next verb is select. Select is the counterpart of filter in a sense, whereas filter operates on rows by choosing a subset of rows that meet a logical condition. Select is used to choose columns. So select, if you can remember my mnemonic for filter, I said filter ends with the letter R, so you know that it's working on rows. Select contains the letter C, and it's working on columns. So that is a helpful way to remember which is which. With select, we can keep or drop columns based on their names and types. In other words, the type of data they contain. So on this simple example on the slide, I'm going to select only the columns pop, country, and year from the Gapminder dataset. If you want to drop columns, all you've got to do is put a minus sign in front of the variable names you want to drop. So to display everything except for population and year, we take Gapminder, we pipe it into the select verb, and then we put minus pop, comma, minus year. And here is another short exercise for you to try your hand at. Take a couple of minutes, and as usual, you can check your solutions against those on the course website. The next verb from dplyr that we need to learn about is called summarize. This verb computes summary statistics. In other words, it collapses a tibble to a single row. On this slide, I'm showing you a simple example where we summarize the Gapminder 2007 tibble. Now remember that that tibble only contained observations for the year 2007. So we're going to summarize this tibble as follows. I'm going to compute the mean of the life expectancy column, the standard deviation of the life expectancy column, and the mean of the population column. So here's the syntax. Inside of this summarize verb, we write the name that we want to assign to each summary statistic. So here I've chosen some simple names, mean life exp, SD life exp, and mean pop. And then we write equals, and then we have the R command that computes the desired summary statistic along with the name of the column we're trying to summarize. So here, mean life exp, SD life exp, and mean pop. It's worth taking a moment to notice that when we're working with dplyr, we don't have to use dollar signs to refer to a particular column in a data frame. This is the special dplyr magic that we get with the help of the pipe and some other exciting things that are going on under the hood, in particular something called non-standard evaluation. It's very powerful, and it reduces the amount of typing that we have to do while still preventing any ambiguity. So as you can see here, we now have a tibble with only a single row, and it tells us the mean life expectancy in 2007 was 67 years, with a standard deviation of 12, and the mean population was around 4 million across all the countries in this data set. You can still use summarize without providing any names for the columns. It'll work. The results are a bit uglier. What R will do instead is it will give your columns names that are exactly the same as the command you used to compute them. And if you notice that the names have these little back ticks, they look like apostrophes, but they're going the other way around. So those are symbols that you can use in R to enclose names that might contain spaces or weird characters that R would otherwise interpret as having some syntactic meaning. So that's the reason those backticks are there. Still works. It's a bit uglier. In general, I think it's a good idea to choose a name that's meaningful to you and short rather than having R do it for you. Okay, now is time for you to carry out another short exercise using summarize to compute some simple summary statistics from the Gapminder dataset. The next dplyr verb that we're going to learn about is called group by. And in fact, group by is going to help us to better understand what summarize is really doing. Summarize, I said before that it collapses a data frame to a single row. That's not exactly right. What summarize really does is it summarizes groups. It's just that in the previous examples, I didn't specify any group. So summarize just treated the entire dataset as a single group. By using the group by verb, I can change the behavior of summarize to get it to give me more interesting sorts of summary statistics broken down by some other variable, let's say. So in this example, I am going to take the Gapminder tibble, I'm going to group it by year, which doesn't actually do anything, it doesn't compute something, it merely signals to dplyr that in the subsequent operations it's going to carry out, it needs to treat the year variable as a grouping variable that determines logical divisions of the data set for the purpose of things like computing summary statistics. So here what will happen when we now pass the result into this summarize command is when we're computing the mean of population and the mean of life expectancy, we're going to do it not using all of the data in the data set, but we're going to do it by year. So we're going to compute the mean in 1952, 1957, 1962, and so on. And you can see that's exactly what's happened here. And because I really like tidy and well-organized results, you can notice I've also taken the mean population and divided it by 1,000,000, so the results here are in millions. You can also group by multiple variables. So if you wanted to compute the summary statistics by year and continent, then you can use group by year, continent. I'm computing exactly the same summary statistics, but now I'm doing it for a much larger number of groups. So I've got 1952 Africa, 1952 Americas, 1952 Asia, and so on. And again, it's your turn to work on a little exercise using dplyr. The next verb that we need to learn is called mutate. Mutate is used to modify existing columns that could change them in some way, or it could even create a completely new column. So here is the example in which we're going to take an existing column and modify it. So I have the population column, which gives raw population counts, and I'd like to turn that into population in millions, because as I said before, I find that much easier to read. So I'll use the verb mutate, and inside I use the syntax that looks very similar to what we saw inside of summarize. We have name equals, and then we have a formula that describes how to compute this particular thing. So I'm saying pop is equal to pop over 1e6. So pop equals pop over 1,000,000. What that does is that overwrites the column pop by replacing it with the same column divided by 1,000,000. Now again, we haven't gotten rid of the original Gapminder data set. We're just displaying this modified one. But what I meant when I said overwrites is it, in the instance of the data frame of the tibble that we're displaying, that column pop has been changed by being divided by 1,000,000. We can also use this to create a completely new column that we didn't have before. To show you how that works, I'm going to create a GDP column. This column converts GDP per capita into a measure that is no longer divided by population. So to do that, I'm going to say GDP equals pop times GDP per cap. And you can see that I end up with numbers that are a lot bigger, as I should. And now it's time for you to try your hand at another short exercise. Finally, we're ready to circle back and talk about how to understand the pipe. We've been using it, but I haven't really stopped to tell you what exactly it is. Here are two blocks of code that do exactly the same thing. The difference between them is going to help us to understand what the role of the pipe is in dplyr and in R more generally. So at the top, I'm going to accomplish a particular task without using the pipe. My command is filter, gapminder, comma, year equals 2007, comma, country equals United States. What does this do? Well, this filters the Tibble gapminder in order to select the rows for which the year is 2007 and the country is United States. I can do exactly the same thing with the pipe. In fact, you've seen me do that earlier in this lecture. And the only difference here is I no longer have to supply that first argument to the function filter. Or rather, I am supplying it, but I'm supplying it in a different way. So gapminder pipe actually pushes the gapminder Tibble into the function filter as its first argument. The pipe supplies the first argument of a function. That's what it does, and that's basically all that it does. It seems like a very small thing, but it turns out to be really helpful when you're carrying out long and complicated data manipulation pipelines. So here is a really silly example. In our base R lecture, we computed lots of means of different little vectors. I'm going to create a vector right now, and I'm going to compute its mean in a way that looks a bit different from what we've done before. I'm going to pipe that vector into the function mean. The function mean needs to have parentheses to show that it's a function call, but I'm not putting any arguments inside. Why not? Because the only argument that I want to use is that first argument of the function mean, which is the vector you want to take the mean of, and here the pipe is supplying that function argument for me. If I wanted to supply an additional function to the an additional argument to the function mean, such as na.rm equals true, remember that's what we need to add if we want the mean function to ignore missing values when computing the mean. Otherwise, when they're present, you're just going to get an na as a result. All I've got to do to supply this additional function argument is put it inside of my call to mean. So again, the pipe is supplying the first argument to a function. In this case, for both the examples on the slide, the first argument of mean is the vector whose mean we want to compute, and the pipe pipes it in. It's also possible to override the default behavior of the pipe so that it supplies a different named argument to a function. This is a more advanced usage. It comes in handy occasionally, not that often, but I just want to show you how it works because from time to time you will see me using it. So as I mentioned before, the first argument to the function mean is the vector whose mean we want to compute. Now, the next argument that I would like to supply in this case is na.rm equals true. If I want to supply that argument with the pipe, I've got a problem, which is that if you look up the help file for mean, na.rm is not the first argument of the function. It's a later one. The underscore allows me to get around this problem. So in my function call, I write na.rm equals underscore. What that means is that the pipe is going to realize anything before the pipe is being pushed into the function where the underscore is. So in this case, the line of code on the slide is going to supply true to na.rm, giving us exactly the same result we had on the bottom half of the previous slide. And here is another short exercise for you to experiment with the pipe and the underscore. The real power of the pipe and dplyr comes from chaining. In other words, putting a whole series of commands in order so that you have one block of code that accomplishes a number of steps in a clean, simple, and easily readable way. Now, I want you to notice very carefully that in all of my examples with the pipe, I have been using spaces and line breaks and indentation. This is really, really important. It's a part of the tidyverse style guide, and it's not arbitrary. As usual, writing clean code is about organizing information in a way that makes it easier for humans to understand. And by humans, very often, I'm referring to you in the future who can't remember what you in the past did and is a little bit irritated with you in the past for not being quite as organized as you could have been. So whenever I'm going to provide a pipeline, I always use this kind of formatting, and you should too. Let's look at what's happening when I chain all of these commands together. I take the gapminder tibble, I push it into the command filter year equals 1982. Now, what would that do? Well, that would give us a subset of the gapminder tibble, only containing the rows for which the year is 1982. Then I push that result into the group by verb, which is going to tell dplyr that subsequent operations should operate on groups defined by the column continent. And finally, I push that result into the verb summarize. And here I'm going to construct the median life expectancy. So this whole pipeline chooses the data from the year 1982, and it computes median life expectancy grouped by continent. Now it's your turn to use a pipeline to carry out a simple exercise with the gapminder tibble. All right, so the pipe is a fantastic tool, but there are some situations in which it's really, really useful, and there are other situations in which it's maybe not so useful. So let's start off with the perennial question: when is the pipe a great thing to do? What are the situations for which the pipe is pretty much tailor-made? Now, I'm going to show you a very, very silly example, but it has the structure of many common data cleaning tasks. So you have a data set, and you need to do something to it. Let's say you want to use a function h to somehow clean some aspect of that data set, and maybe you need to supply an argument to h. I'll call it arg1. Okay, now when you're done with that, the function dat has the data set has changed. So now you're going to have to do some other step, let's say, g. Well, then you've got to do g of dat with some argument, and you've got to overwrite dat again. And then maybe there's some other step that you need to do in your data cleaning. But let's call it f. So now you've got to apply f to dat with some other argument, and then overwrite dat again. You could do it with multiple lines, where you're constantly overwriting dat, but you'll notice that when you do that, you've got to write the name of your data frame 6 times, which is a lot of typing. Now, the other thing is that at different stages along the way, lines 2, 3, and 4, the state of your dataset dat is different. So if you only ran line 3, for example, and you didn't run line 4, you might not be able to predict exactly what the state of your dataset is. So there's a couple reasons why that might not be the best way to go. Let's see how much nicer this is with a pipeline using the base R pipe. Here I pipe dat into h with arg1, which I then pipe into g with arg2, which I then pipe into f with arg3. It's nice, it's clean, it's easy to read. Now on line 13, and I chose 13, well, I didn't really choose it on purpose, but it's ominous, isn't it? In line 13, we can see how this is actually evaluated. So the way that this works is this whole pipeline is equivalent to the following line of R code. Now, you could program this way. You occasionally see people doing it. But let me show you why, even though this would give you the same result as the pipeline, it's not the best way to go. F of g of h of dat, arg1, arg2, arg3 would give you exactly the same as that pipeline, but notice that the way that we read is left to right, but the way that this code is actually evaluated is right to left. So the h function comes first, then the g function, then the f function. Writing it the way that I've done in line 13, it will run, but it's very hard for a human being to read compared to the pipeline above. The pipeline also avoids the need to retype the word dat over and over, as we had in the first version of this code block at the top of the slide. It is possible to go a little bit too crazy with the pipe, though. So as a general guideline, it's best to avoid really, really long pipelines. So as a rule of thumb, maybe a maximum of 10 steps is a good place to cut things off. And ideally, you want to group conceptually related steps together. Because again, the point of the pipe is to make code easier to understand for human beings. Of course, as George Orwell once wrote, and it's very important to bear in mind not only in writing, but also in coding, You should break any style rules sooner than you should say anything outright barbarous. So these are guidelines that I'm providing. They're usually helpful, but they might not always be appropriate. If you've seen a lot of our code before, or if you look at large language models, which have seen a lot of our code, you may notice some command that looks similar to the pipe, but has percent signs rather than that vertical bar. So older dplyr code, including Core ERM 2022 version, uses this alternative version of the pipe. This comes from a package called magrittr, and if you want to see something that, if you like puns and you want to see a funny pun, go check out the magrittr package. So it works very similar to the pipe that I've just shown you, the one that we've been using throughout this lecture. To quote a great Stack Overflow article about this, the base R pipe is a little bit faster, it's a little bit simpler, and it's a little bit more robust. There are some subtleties, and if you click on the link on the slide, you can read more about them. But for the purposes of this course and in my own work, I'm always going to use the base R pipe, and I recommend that you do the same. There is, of course, always much more to learn. We're going to be learning more about dplyr throughout this course, but as I mentioned today and in our first lecture, I'm not going to be able to cover everything that you need to know. So it's very helpful for you to do at least some additional reading on your own now. A good place to start is with the references at the beginning of this lecture.